Alright, so in the previous lesson, I hinted that there are some useful commands that we can include within our Splunk searches to give us some more functionality and enhance the effectiveness or precision of our data analysis. And so while the search terms that we covered in the previous lessons are the foundation of our search queries, we have some commands that can tell Splunk what we want to do with the search results, like creating charts, or running statistics, or even more advanced formatting of the data. And so first off, we have the sort command. And the sort command is used to order the results of our search based off of one or more fields. And we can specify ascending or descending, and allow us to organize the data in a more meaningful or relevant way, depending on what we're searching for. And it's important to note that when we want to run commands like this within our SPL searches, well, we can use the pipe character, as you can see here, which is very similar to bash, which is the character we can use to connect different commands together. And so it acts as that way to pass in the output of one command into the input of the next command. And so with sort, say for example if we wanted to sort our logs in chronological order, but not by using Splunk's normalized time column here, maybe we want to use the raw timestamp or some other field in our data. Well, we could reference the specific field. And so if I open up one of these examples here, well, you can see we have the request time field here. And so what I can do is pipe this over to sort, and then just specify the actual value of that field, so request_time. And typically what you'll find is to increase the readability of our search, well, instead of having this all on one line, we'll add a new line and put our pipe under that. And so this command is going to sort the events based on that request time field in ascending chronological order, meaning that the earliest events will appear first, which you can see here. And so now we're not ordering the events based on the built-in time column, but rather on the specific request time field. Which in this case, we're not really going to notice a difference, but this is how we can sort of do that kind of thing. And if, for example, we wanted to reverse this order and show all of the events in descending chronological order, or in other words, the most recent events first, well, we can prefix the name of our field here with a minus. And now if we run this, we're getting the most recent events first. And once we start putting some statistics together, well, the sort command is going to become more relevant. And so now, we also have the super powerful stats command. And the stats command in Splunk is a powerful statistics function that we can use to aggregate and summarize different data. And there's quite a lot we can do with the stats command, like calculate the average values of a field, or return the max and minimum values, or even do things like add and return the sum of values or count the occurrences as well. And so just as an example, let's count up the IP addresses that were listed out as connecting to our web server in the logs. We can then sort them by top values. And so I'm just going to run stats here, and then we want to count, in this case, the actual occurrences. And when we do this, we need to specify the field that we're counting. And to do that, we can use the by clause, and then specify the name of the field. And so in this case, client IP. And if I run this, all right, now you can see this table. We've been moved over to the statistics tab here, and now we're just extracting out all of the IPs that were listed in our log events, along with, on the right here, the count of their occurrences. And so again, this is similar to what we were doing manually in the command line, just a lot faster. And so now what I can do is pipe this to yet another command here, and this time I can sort. And what I can sort off of is this actual count column or the count field that we generated. And to put it into setting order, I can use the minus sign here and then specify the name of the field, so count. And this is going to bring up the top values. And so there we go. And so we can see 62.122.201.246 has the count of almost 3,000 here. And lastly, I can pipe this one more time over to the head command. And this is another new one, but not so new if you remember back from our command line days. And so just like on Unix-based systems, this will limit the amount of lines that are returned. And in this case, I can specify the number 5 to only pull back the top 5 IP addresses based on their count of occurrences in the logs. And there we go. So you can see we're only pulling back the top 5 results. Similarly, this won't really be useful in this example, but instead of head, we can use the tail command to, again, do the same thing, but only pull back the last 5 records in the list. All right, awesome. And so next, we can look at the table command, which is used to format and display specific fields in a tabular format. And so this command is especially useful if we're trying to create reports or visualize our data in a more structured way. And so let's return to our original query here. And now we can see a ton of events returned. But we're not really getting many useful fields listed out in our table, right? However, if I open up an event, well, we can now start to see all of its associated fields. And so let's try building out our own table to list out things like the IP address, or the client IP, and the request method, and the URI, and the user agent as well. And so to build out our table, it's actually quite simple. We just need to pipe this over to the table command, and then just specify the name of the fields that we want to put in our table, and then make sure they're comma separated. And so first, we might want to use the built-in or the normalized time field to make sure that we're pulling back the actual timestamps. And then after that, with a comma, I'm going to input the client IP field, then the method, the URI, and lastly the user agent. And so after running all this, well, we can see again, we were brought right over to that statistics tab, and we've built out a table containing all of the records with all of these extracted fields or columns. And so now it's much easier to look at the information we care about, and we can even use these column headings here for more additional filtering. And so let's build on this table and introduce some more commands. And so first we have the dedupe command, which you'll recognize is similar to the unique command we were running in the terminal. And so dedupe is used to remove duplicate events based on specific fields. And so obviously it's particularly useful if we want to ensure that only unique events or records are returned with our results, to eliminate that redundancy. And so let's use this to remove any duplicate user agents. And so we can just focus on the unique values. And so to do this, we just need to provide the name of the field. And so dedupe user agent. And if I run this, well, now we're only pulling back an aggregation of the unique user agents. And so it's a lot quicker for us to identify things like Hydra or Nmap. However, let's make this table a bit more presentable. And to do that, we can pipe this to the rename command. And this allows us to, as the name suggests, simply rename one of these columns to whatever we want. And so this won't affect the actual logs themselves, or make any modifications to the data. It will just change the way in which our charts or statistics refer to the field or column itself. And so instead of user agent in all lowercase and one word here, we can change this to be more presentable for, say, a report that we wanted to run. And so I'm just going to select rename here, select the name of the field, so user agent, and use the as clause here to change this, in quotes, to user agent. And obviously we could do this for any field here and also name it whatever we like. And so if I run this, well, we're going to get the exact same results. However, you can see our user agent column here is a lot more readable. Now, as a quicker way to pull back, say, the top or bottom values, well, we can use the top and rare commands respectively. And so the top command returns just the top 10 events, and we can also limit this as needed. And so for this to make sense, we have to enter this before our deduplication and renaming, as every change we make as we pipe the output through means that our query and the data we have access to changes as well. And so what I'll do is just delete these lines here, and under our table, I'm just going to include the top command. And I'm going to set the limit argument here to equal 5 to only pull back the top 5 events. And then I can specify which actual field I want to pull the events from. And so in this case, I'm just going to select user agent. And so this is another quick way for us to get just the top values, along in this case with their percentages. And I can simply change top here to rare, which does the opposite and returns the least frequent values. All right, so now let's quickly talk about some visualization options that we have as well. And so just for a very basic example, let's create a visualization depicting the different status codes across our data. And so to do that, I'm going to delete our table here, and I'm just going to add the chart command. And again, as the name suggests, this allows us to create charts with our data. And so when we do this, we can add the count argument with the by clause, and then specify the name of the field that we want to create the chart or visualization off of. And so in our case, let's use the HTTP status codes, which is just called status. And now when we run this, you can see we were brought to the statistics tab, as most of the chart commands utilize various statistics or stats commands to aggregate its data. However, let's click on the visualization tab here. And you can see by default, Splunk has generated this bar or column chart depicting the 3 different values and their counts. And now we can change the actual type of visualization or chart that's being generated as well by clicking here. And so we can change this to, say, a pie chart, or maybe a filler gauge chart as well. And these aren't super useful or relevant with the type of data we're returning. And so, for example, let's get a bit more complicated here and look at request counts for specific IP addresses over time. And so I'm just going to clear out our original query here. And so if I click on the client IP field, we can see again, this 62.122.201.246 address is the top talker in this log source, and was the IP address that was found to be brute forcing the website. And so what I can do is specifically pull back the records associated with that IP. And so I can do that with our field parameter here of client IP and set that to equal to 62.122.201.246. And this time we can use the time chart command. And this allows us to create charts that show the distribution of events over time, making it ideal for trend analysis or pattern matching or baselining, and even performance monitoring as well. And so what I can do here is add the span argument to specify the actual time interval that we're searching for. And so in this case, I'm going to set this to 1s for 1 second. And then I just want to look at the count of individual records for this IP address. And now if I run this, well, we can head over to the Visualization tab and change this, in this case, to a line chart. All right, so now we're getting some interesting information, right? And so we can start to see the trend, in this case, of the initial Nmap scan that the attacker ran. And then, as we scroll through, we can see the actual brute force attack that ramped up half a minute later. And based off of this trail at the end here, well, we might be able to infer that the attack ended around here, which was likely around the time that the attacker got a successful login and stopped the attack. And we can click on any point in this line here to bring up the timeline related to those events. Lastly, I want to point out that we can nest various search commands within sub-searches. And so it's probably better just to demonstrate this. And so what I'll do here is just create a table. And within our table, I want to select the time and the client IP. And for this example, just the user agent. All right, so now that we're pulling back this subset of data, I can pipe this into a nested search command here and perform a wildcard field search to pull back any user agents that contain the word Nmap, for example. And so to do this, I can just pipe this to the search command, which basically allows us to just run another search using this data that we're pulling back. And so what I'll do is search for the user agent column and set that to equal wildcard Nmap with another wildcard. And now if I run this, and what I need to do here is set my time range to all time. All right, and there we go. And so we're matching any records that have Nmap in the user agent. And so using this nested searching and different commands, we can get pretty sophisticated with what we're pulling back within Splunk. All right, and lastly, I want to showcase one more thing. Since we have a lot of logs here with different IP addresses, I want to show a really cool command that we can append to our search queries. And that's the IP location command. And this is a super useful command that we can use to enrich our events and give us that geographic and contextual information about the connecting sources or destinations. And this command basically just extracts the location information from IP addresses using third-party databases. And so we can just run our search query here and then pipe it over to IP location. And then just select the field in which we want to pull IP addresses from. And so in our case, it's going to be client IP. And it's really just that simple. And so let's run this. And nothing really changes. However, under interesting fields here, you can see we have city and country. And so if I open these up, well, we can see the actual locations of these IP addresses that are accessing the web server. Really cool stuff, right? And we can see the actual top values for the cities and countries as well. And it saves us so much manual time instead of performing these lookups ourselves. And of course, we can add to this query, right? And so we can use the country and city field as columns in a table, for example. And so I can pipe this over to table and select things like the timestamp, and then the client IP, the country, the city, and say, for example, the URI. And now if I run this table, well, you can see how much more useful our table is becoming. And of course, we can also use this for visualizations as well. And so what I'll do is just delete this line here, and I'm going to pipe this over to the geostats command. And the geostats command is used to generate statistics specifically for displaying geographic data. And we can use it to summarize this data onto actual maps. And so what I'll do is just run the count argument here with the by clause on the country field. And if I run this and hop over to visualization and change this over to something like the cluster map here, well, how cool is that, right? We're getting an actual map view of all of the different connections and where they're actually located in the world. And now, again, that was a lot to cover, but hopefully really cool. But lastly, I'll say that we didn't even cover every single command and everything possible with SPL and different chart options or other stats calculations. It just wouldn't be practical or even an efficient use of your time. However, we did cover the fundamentals and even a bit more as well, and this will set up nicely for some hands-on investigations. And so as you start using Splunk in different SIMs more and more, you'll start to get a grasp on the general commands that are available to use, and how they can save you time or make your searches more efficient.